All right, so today we're actually learning the very last thing that is in this chapter. So we've learned all the math. You guys know how to do all the math already. Today we're mostly going to be doing word problems. So it's more about like reading the word problems and translating it into math. So that's what we're going to be working on today. And whenever we have word problems, I'm going to be needing some good volunteers. So today there will be a few of them. Can I get our first volunteer of the day to read our first problem? Sue.
Sue is buying t-shirts and shorts. T-shirts cost $14 and shorts cost $21. She plans on spending no more than 147 and buys at least 5 items. Show and describe all combinations of the numbers of t-shirts and shorts she can buy.
Perfect. Okay. So this time we're working with inequalities. Okay. So inequalities, not equations, which means what type of symbols are we going to be seeing?
Greater than and less than and equal to.
Exactly. So we're going to be looking for greater than, less than, greater than or equal to, less than or equal to. So what we're going to look for when we read these problems, the first thing you're always going to look for is keywords that will help you identify the right symbol to use. So what keywords do we see that will indicate if it's going to be greater than or less than?
No more than.
At least. No more than. Perfect. You guys got it. So spending no more than, and then buy at least 5 items. That's always the first thing. If you, on your test, you're allowed to highlight it, write it down, do what you can to just call attention to those keywords. The next thing we're going to do is with these problems, you always want to be very organized because this one's not too hard, but sometimes you'll see a long paragraph and most of the information in that paragraph is not important, but you have to find what matters. So to be organized, we're just going to write some stuff down. I always want to write down what the variables are representing. So read it carefully. What does X represent?
Number of shirts.
Good. The number of t-shirts. And then Y is the number of shorts. So I have shirts and shorts. And then we know that there's going to be a system. How many equations are there in a system?
2.
2. At least 2. So we know that there's going to be 2 equations or inequalities. So we're going to begin by what we highlighted. Go back to what we highlighted. And we know that one of those equations is going to have to do with money. So where else do we see numbers that have to do with money? What else can I highlight in orange?
The prices of the t-shirts and shorts.
Exactly. T-shirts cost 14, shorts cost 21. So I'm basically trying to keep all of the information that belongs together, I'm keeping it together. Well, since I'm going to write an equation that has to do with money, let's start writing that down. So I know it's $14 for each t-shirt. So that's going to be 14 times X. And then $21 for each pair of shorts, so that's 21Y. And then I know that, it has to do something with the number 147. Now I haven't written I don't write an equal sign because I know we have to pick the right symbol. Is it going to be greater than, less than, greater than or equal to, or less than or equal to? And here's where we have to be the most careful. This is where a lot of times it can go wrong. So I want you guys to watch what I'm doing and copy it down. These numbers is what Sue actually buys. That represents what she buys. And 147 represents kind of her budget, right? What does it say about 147?
No more than 147.
no more than 147. So is that a maximum amount that she can spend, or is that the minimum amount that she can spend?
Maximum.
That is the maximum. So whatever Sue buys, do we want that to be less than 147, or do we want that to be more than 147?
Less than.
Less than. So whatever Sue buys must be less than,
Can it be less than and equal to?
and I was just going to ask, can it be 147? Read it carefully.
Yes.
Yeah, definitely. It doesn't say that it can't be 147. It's just telling us that she can't go over 147. So this is going to be less than or equal to. So whatever Sue buys must be less than the maximum amount. And so the words that I just wrote down underneath, the reason I wrote them is because sometimes it's easier to turn words into math when you are kind of organized the way that I did it. So if we only read the orange part, I literally wrote what Sue buys is less than the maximum. In algebra, that's 14x plus 21y is less than or equal to 147. So do I have any questions on how I wrote that inequality or how I chose my symbol?
How did you choose your symbol?
How did I choose the symbol? So the first thing I had to decide is whether the number 147 is the maximum amount or if it's the minimum amount. And that just comes from reading the problem. So I realized, okay, she can't spend more than that, so that's my maximum. She literally can only spend up to $147. Since that's the maximum, then whatever she does buy has to be less than that, less than or equal to that. So that's how I chose the less than or equal to symbol.
Okay, thank you.
No problem. All right. Well, now we got to do the same thing. Remember, you guys said we have to have two equations at least, two inequalities. So I know that there's another inequality that has to do with the number 5. Well, she needs to buy at least 5 items. What are the items she's purchasing?
Shirts and shorts.
Shirts and shorts, right? So however many shirts, however many shorts has to be at least 5. Well, I have these variables here. X is the number of shirts, Y is the number of shorts. So the number of shirts plus the number of shorts. And then I know it has to do something with the number 5. So I'll do this again. What she buys and then the number 5, is that a minimum or is that a maximum?
Minimum.
Good. And that, again, goes back to just reading it carefully. She needs to buy at least 5 items. So 5 is the smallest amount that she can have. That's the minimum. So what she buys, does that need to be greater than or equal to 5? Or should that be less than or equal to 5? Greater than
Greater than.
or less than?
Sorry.
Go ahead.
Greater than or equal to.
Greater than or equal to. And again, let me write this down. Whatever Sue is purchasing must be greater than the minimum, right? She's got to stay above 5, but she has to stay below $147. So those are my two equations or inequalities. Is anybody still wondering how I came up with those values or those symbols? Okay. All right. Well, whenever you have a real world problem, the other thing that you might be asked about is whether or not a certain combination is going to work. So look what they said. Show and describe all the combinations of numbers of t-shirts and shorts that she could buy. So what I'm going to do next is I'm going to write down some possibilities. And I want you guys to tell me if they work or if they don't work. All right. So for example, let's say she buys 3 shirts and 2 shorts. Will that work?
Yes,
Okay, now how do you determine that? What do you have to figure out?
because it's an equal to sign, so it can be 5.
So it can be 5. Okay, so 3 shirts and 2 shorts, that works. It's equal to 5. So she hit the minimum amount. Now, does it fit under the maximum?
Yes.
Okay, and how'd you figure that one out?
Because it's less than 147.
Right. So we know that the shirts are $14, right? Shorts are $21. So you basically plug it into this equation, right? 14 times 5, no, 14 times 3. What did that give you? Three shirts, that's $42.
$2.
And then 2 shorts, 21 times 2, is 42 as
Also,
well. We add that up, we got 84,
84.
right? So she's under budget, so that's fine. So that works, right? Well, I'm just gonna write this instead of 3 shirts and 2 shorts, I'm just gonna write this as 3 comma 2, because the shirts is the X and the shorts is the Y. Okay, here's another possibility. What about 5 comma 0?
Will work.
Works?
Yeah.
5 times 14, 70. Good, that works. Okay, here's another. What about 0 comma 8? What if she just feels like buying 8 shorts?
That's over, so it will not work.
All right, that's
168.
168, so that does not work. But what about this? What about negative 2 comma 8?
It will work.
It will work.
It works, right? However, can I have a negative amount of shirts?
No, so
Is she selling them?
No, right? It's at a store, so she can't sell them because she doesn't work there. So that is an example of something that, even though it works mathematically, it doesn't work if we're talking about a real world situation. So that actually doesn't work. Make sense?
Yes.
What about something like this? 2.5 comma 4.5.
no, because you can't
No,
like
you
buy
can't
a
buy
part of
half.
something.
Right. So it might work mathematically, but it doesn't make sense in the real world. So that doesn't work either. Pretty straightforward, right? But something that you always want to keep in mind when you're plugging numbers in, don't just plug numbers in and it's like, oh, the math works out, we're good, awesome job, nice, done. No, step back for a moment and think, does this make sense in the real world? Any questions on this one so far?
So pretty much the way to think of this in a real world scenario is, just because the math works doesn't mean that it's logical.
Right, so that's the key word. We're trying to be logical about it. Exactly. Any other questions? Awesome. All right. Here's another example. It's very similar. Can I get a volunteer to read this one for me?
John has to buy two different kinds of rope. Rope A costs 60 cents per foot and rope B costs 90 cents per foot. John needs to buy at least 15 feet of rope, but he wants to spend no more than $18. Show and describe all combinations of the number of feet of each type of rope John can buy. First, write. Oh, do I have to read that?
Yeah, go for it. Finish it off.
Okay. First, write the system. Let X represent the amount of rope A and let Y represent the amount of rope B.
Perfect. Okay. So X is rope A, Y is rope B. That's always going to be one of the first things I do is like just write that down, because later on you're going to see actually the next example is more challenging, and we always just want to keep things super duper organized so that we don't lose track of everything. So that's the first thing I write. Next up, I'm looking for my keywords. So where are my keywords that tells me what type of symbol I'm going to need to use?
You want to spend no
Buy at
more.
least.
Good, I heard both of them. No more than, and then at least 15 feet. Okay. Oh, let me highlight them in different colors just to, and I don't remember on your test, does anyone remember off the top of their head if performance matters lets you use different colors of highlighter?
Wait, what?
Like
Oh
when
no,
you,
it doesn't.
it doesn't, or is it just, it's just yellow?
It's just yellow.
Oh, okay.
Yeah, it's yellow.
Well, in that case, if you can't use different colors, something you can do instead is just write things down underneath, like just write them down instead of highlighting them. But
Or you could use the highlight feature and then just take it off and use right and then just
yeah,
pull
so
down.
like focus on, yeah, that's another way to do it. Like you could focus just on the money first and then erase it, and then focus on whatever's not related to money and then erase it. That's another way to do it.
Oh no, I meant like the highlighter. I'm gonna use like the normal blue select.
Oh, like with your cursor, like on just the screen. Yeah, that's another way to do it. Nice. Okay. So now again, we're just going to match things that match together. So I see $18. What does that match with? What else can I highlight in orange?
How much the rope costs?
Good. So we want to keep money with money. Anything that's not money is going to be a separate equation. So rope A is 60 cents. Rope B is 90 cents per foot. Okay. Now, can anybody give me an inequality based on that? Or at least, even if you don't know the symbol yet, just the numbers.
A, well, it would be, I guess, 60,
Mm-hmm.
0.60 x plus 0.90 y equal, or I guess
We'll figure
greater
that
than,
part out. Yeah.
yeah, 15. Oh no, 18.
18. Good. Good, good. Okay, now we'll figure out what symbol it needs to be. Is 18 going to be the maximum amount or the minimum?
Maximum amount.
Good. No more than, right? So he has to spend less than that. So that's the maximum amount. And whatever he buys, this is what John buys,
Has to be less than or equal to.
has to be less than or equal to that. Exactly. Less than or equal to. So that is the strategy. Anytime, and I know that these questions, the first one we did and this one, are a little bit simpler. Maybe you don't think they are, but compared to what we're going to see next, these are a little bit more simple. But it's better to do the strategy for the simple problems so that you perfect it and can do it on the harder problems. So what John buys has to be less than the maximum. Same thing, now we have this 15. He needs to buy at least 15 feet of rope. So I know there's going to be a 15, but what exactly needs to add up to 15?
The amount of rope that he needs, the number of feet.
Yeah, the amount of rope. So the amount of rope A, well, that's just X. The amount of rope B, well, that's just Y. So again, what he buys buys. Now in this case, is 15 the maximum amount or the minimum?
Minimum.
That's the minimum. Because it says he needs to buy at least 15. So he better be getting more than 15 if he wants to have enough. So whatever he buys must be,
At most $18.
well, that's the money, but the amount, whatever he ends up buying, has to be what?
At
Greater
least
than?
15.
Should it be?
Oh. Greater than or equal to.
There we go. Must be greater than or equal to the minimum. Okay, the amount of rope that he buys has to be more than 15 feet and less than $18. Questions on the two inequalities? Okay, now let's again do the possibilities, see if they work or if they don't work. However, I'm going to introduce a new easy little vocabulary word that might come up. When something works, another way to say that it works is to say that it is viable. So you might see that come up. That's why I'm putting it here. So viable and then not viable. That's just the same. It means the same thing as work. So it works or it does not work. It's viable or not viable. I'm going to put a few options. I want you guys to start thinking about them as I put them down.
The first one is viable.
Okay. Let me finish writing them down. I'm almost done. I have a few more.
Oh, I have a question. Are we including tax?
Pretend tax does not exist in this world.
That sounds heavenly.
I know. All right. So the first one, viable or not viable? 10
Viable.
comma 5. Does it fit in the budget?
Yes, it is.
Good. Viable. The second one, 10 comma 10.
It is barely viable.
Barely viable. What does that mean?
It's $1 off.
How much does that come out to?
$17.
$17. So it's still under budget, still works, but barely. How about 3 comma 5?
Viable.
It's under budget,
Yeah.
but I see another problem with it. A different
It's
problem.
less than 15.
It's less than 15. And remember, we need at least 15 feet. This is only 8 feet. So it's not long enough. Not viable. How about the others? I see some decimals. I see some interesting situations. What do we think of those?
Well, the decimal ones aren't inviable or not viable because you can't buy. Actually, you can buy half a feet of rope, right?
Yeah, you can. So
I
here's
mean,
so that's exactly what I was going to say. In the previous problem, we were talking about t-shirts and shorts, right? You can't buy half a t-shirt, you can't buy half a pair of shorts. But now we're
it's
talking
still-
about feet.
It's still over budget though.
It's over budget, isn't it?
Yeah.
What does it come out to?
Or $18. I don't. It's that's so much
Yeah.
math for me.
Does it fit in the budget? Take your time. Do the math slowly. Can anyone tell me if that fits in the budget? 2.5 and 15. What was that, Ascanio?
I think it does.
Yeah, I think it does too. The
It does.
yeah, right? 2.5 times
0.990 times 15 is I think 15, right?
use your calculators. 15 times 0.9, I got 13.5. And then 0.6 times 2.5,
$1.20.
$1. Yeah, so we're good. We're under budget. That actually works. It's viable. How about 2.5 and 10?
That is not viable because it's not 15. It's not over 15.
Good. We're trying to get over 15 feet. That's not long enough. Not viable. How about 10 comma or 18 comma negative 2?
Doesn't
Not viable because it's over budget.
It's over budget. It's not over. Wait, is it 18 times 0.6?
no, it's negative.
1.8? Oh, why is it not viable?
Just negative.
Negatives. Can I go into a store and ask for negative amounts of rope?
No.
No.
Oh,
that
but you
doesn't
can take away the rope.
That would be illegal. I'm not trying to break the law. Thank you very much.
Ow. You would just take away the rope from the 18, so it'd be 16.
No, that's not how it works. So negative numbers in general, if you're in the real world, just think about it. I mean, I'm not saying it's always going to be not viable, but most of the time, negative numbers don't make sense in the real world. So those are most of the time, those don't count. Decimals, a lot of the times, decimals don't count in the real world. Sometimes they do, like in this problem, they do, but a lot of times they don't. So again, you have to read it carefully and think about it in that context. Now, I'm seeing a couple of questions in the chat, so I just want to address those. Those of you who are answering me, how are you doing the math? So let me just give one more example. 9 comma 6. So if that was the possibility, how did we check if it was viable?
Plug them in.
Yeah, plug them in. So this is my rope A, which is X. And this was rope B, which is Y. I have these two, let me circle them. I have my two inequalities. I'm just plugging those numbers in. That's all we were doing. So in case you were a little confused just now, that's what was going on. So I plugged in 9 for X and then 6 for Y. And then we were trying to see if it was under $18 and over 15 feet. That's all we were doing. So any other questions on that? Awesome. So next up, now we're going to see what it looks like when the problem is just a little bit more challenging. I'm not going to say that it's like the most challenging thing ever, but you'll see when you look at it why it might appear to be a little more challenging. So what are your first thoughts when you see a question like this?
Too many numbers, too many letters.
Too many numbers, I completely agree with you.
Much words.
Mm-hmm. It's just so much, right? You look at this and it's like, man, am I taking iReady reading right now? Like, what is going on?
How
Which is
about we
why
skip this and then do independent practice instead?
you wish. No. We're going to follow the same exact steps that we were following before. What should be the first thing I write down on my piece of paper?
What X is and what Y is?
Good. So look through the question. Just read that part. What does the X represent and what does the Y represent?
The number of small packages and Y is the number of large packages.
Good. X is the number of small packages and Y is the number of large packages. Okay, we got that down. Next up, we're going to highlight the key words for greater than and less than. So skim it slowly, but where do we see those?
It says in the beginning, it says the delivery truck can hold at most 380 pounds. So it at most.
Good. at most, and then always highlight whatever unit it's working with. So in this
Pound.
question, it was money and feet, but right here we've got pounds, right? So pause there, and now let's look through and see where else am I highlighting with orange? Where else do you see pounds?
No more than 400 cubic feet.
Okay, that's cubic feet though, that's not pounds. Where else do we see pounds?
Small package weighs 30 pounds, and large package weighs 6.5 pounds.
Perfect. Small package 30 and large package 65. I'm going to ignore everything else for the moment, and let's just start by writing that one inequality. So I want you guys to try that on your own. Think about, just look at what I highlighted, ignore everything else. What are you going to write in your inequality that puts all those numbers together? I'll give you guys a minute to try it on your own, and then we'll do it together. All right, that was a minute. Now let's talk about it together. All right, so first things first, I have these three numbers. I'm not going to think about the symbol quite yet. Let's just put them together and leave a space where we're putting the symbol. What can I write down?
30x plus 65y, and then 3,800.
Good. 30x plus 65y, leave a space, 3,800. Now we figure out the symbol. Is 3,800 the maximum or the minimum?
Maximum.
Maximum.
Good, that's my max. Which means whatever is in the truck must be what?
Less than or equal to.
Must be under that, right? Must be less than or equal to. See how, even though this was a much more complicated problem, we're still doing the same exact steps. That's how we break it down. And that's how I want you guys, that's the strategy that we're working on here is what you guys can do on your own when you take the test. Follow that same exact strategy. Same, as long as it's super organized on a piece of paper, you'll be fine.
When
Now,
is the test for this?
what was that?
When is the test for this?
Who wants to answer him? When is the test for this?
Monday and Tuesday.
Monday and Tuesday.
Okay.
That wouldn't be the midterm, right?
No, you guys already took your mid-year. That was back at the end of the year, right before Christmas break.
Okay,
25th and
yeah.
26th.
Yeah, you guys already did it. All right, so now I want you guys to, I'm not going to highlight anything. I'm not going to write down anything. I want you guys to try and figure out the second equation on your own, but use that same strategy, okay? So you can highlight it on your screen. Well, I don't think you can actually do that, but you can write things down on your piece of paper, connect the other numbers that we see on the screen. 2 minutes. All right. All right, so I've seen some completely correct answers. That's good. Let's see if we can piece this together. Where's my keyword for my symbol? What's the keyword?
Cubic feet.
That's not telling me the symbol though. I
Oh,
mean, that
No
is
more.
important, but
no more than.
there you go. No more than. No more than. And that's super important. If you miss the word no, you might have gotten that part wrong. So it's no more than 400 feet, 400 cubic feet. And then what numbers go with that?
400.
Oh, I see why I got it wrong.
What are the other numbers? So I see a 4, right?
A 9 and a 4.
A 9 and a 4. Okay, cool. So very similar. The 4, does that go with the x or the y?
X.
4x, 9y, I'll leave a space, and then 400. Well, if it can't be, it's no more than 400, is 400 the maximum or the minimum?
Maximum.
That's the maximum. Which means whatever I have in my truck better be less than or equal to 400. So there we go. I've got my 2 equations. Now let's look at the answer choices to figure out which one it is. What do you guys notice?
They're both greater than or equal. No, less than or equal to.
So they both have to be less than or equal to. I'm noticing something else too.
I know there's no answer for it.
Interesting, right? Where's this 6x and the 13 and the 15 and the 2? Where is that coming from? What is going on?
Magic. Can we
Magic.
look at that? Yes. This is a universe where magic exists.
So is it B?
Is it B? Let's find out. How would they get? Okay, well, I look at B and I see that my bottom equation matches, so that's good.
So they multiply the top by like 5?
Oh, it seems that there was a little bit of multiplication, maybe a little bit of division going on, right? Because this top equation, how do I go from what I have to what they have?
Division.
Division, right?
You
They
divide
got
by 5.
good. Everything got divided by 5. Now, is that something we can do?
Yes.
Yeah, what did we learn last week? That if you multiply or divide, you still have an equivalent system. So even though they basically divided everything by 5, that still keeps things equal. It still keeps things equivalent. So that's it. That is my answer. Do I have any questions on this one? I would say that that last bit right there where they divided, that was probably kind of a trick that they always pull some sort of trick on you. You just have to watch out for those things, okay? But what we did when we got our answers, we followed everything perfectly. So I knew that my answers were correct. So it was just a matter of matching my correct answer with whatever I see on my screen. Any questions on this one?
No.
No. Okay. All right. So let's do a couple more. Now, sometimes we talked about this. There usually a system has how many equations?
2.
Two, right? Well, sometimes in the real world specifically, every time when you have a word problem, you might have more equations only because, remember what I said, in the real world, you can't have negatives. Sometimes you can't have fractions or decimals. Sometimes there's more what we call constraints. Okay, the word constraints basically just, it's like limits that you set. Sometimes there's just more limits in what we can have. So here's a good example of that. Can I get a volunteer to read this one, please? Who can read?
A standard elevator in a medium-rise office building has a maximum capacity of 17 people and can hold a maximum of 2,570 pounds. The average weight of an adult is 195.5 pounds for men and 166.2 for women. Select all the inequalities that model the contains for the situation where X represents the number of men and Y represents the number of women.
Awesome. All right. Well, we're just going to start this off exactly the same way that we've been working, okay? What I want to do first is figure out which of those options are the two equations that we're used to writing, just like exactly like we did in the previous problem. So what do I always write first?
What the variables stand for.
Okay, good. So X is the number of men and Y is the number of women. Okay, well, if that's the case, let's go ahead and now let's highlight our keywords. Where do we see our keywords?
Can hold a maximum.
A maximum.
There it is, yeah. So maximum capacity of 17 people and maximum of 2,570 pounds. All right, what numbers go with pounds?
166.2 and 195.
Good. So the average weight of a man and the average weight of a woman. Now we're ready to write some equations, inequalities. Starting with the one that has to do with pounds. How can I begin that one?
One 195.5x plus 162.2, and then you put the circle thingamajig, 2,570.
Okay. Now in this problem, it's super straightforward. We know that 2,570 is the maximum because that's what it literally says. So whoever's on the elevator has to be
At least less than or equal to that amount.
less than or equal to that amount. Can't hold it anymore. All right. Oh, that's 166.2, my bad. So there's one equation, or inequality, I mean. Now, what about the 17? What has to be maximum 17?
The amount of,
Capacity.
That's
The amount of
capacity,
people.
right? The amount of people. So are there numbers attached to the amount of people, or can I just write X and Y?
X and Y.
X and Y.
Just X and Y, right? The number of men plus the number of women has to be what? Above 17 or less than 17?
Less than or equal to.
Less than or equal to. So there's two inequalities. Those are the ones that we know how to do without a problem. So what can I check mark? Let's see, I can check mark the bottom one for sure. I can check mark this one for sure. Wait, not that one. No, what's wrong with that one? My bad.
it has the
It has
Yeah. If I read that one out loud, what it would represent would be that the number of men and the number of women has to be less than 2,570. So this is claiming that you could have 2,570 people on the elevator. That doesn't
that's
make
too
sense.
big of an elevator.
Yeah, that sounds like a claustrophobic situation.
No, that would just be like, hey, you have to yell across the entire elevator just for somebody to press your floor.
All right. And then the next one, we know this one matches. Okay. Well, now let's just take a look at what the rest of them say, just to kind of understand what they're actually talking about. How would I put this top one into words? X is greater than or equal to 0.
The minimum amount of people is 0.
And just people?
And the minimum amount of men.
Men, right? So basically this is saying that the number of men has to be greater than or equal to 0. What types of numbers is that basically denying? So what type of numbers would not be greater than or equal to 0?
Negative numbers?
Negative numbers.
Negative numbers, right? So this is basically
Negative
telling
numbers.
me, I can't have any ghosts on this elevator. All the men must be positive numbers. Right? Like that makes sense. I can't have negative people on that elevator, negative men. And then this one is
Yes.
basically just telling me that the number of women
Says who that you can't have a negative amount of people.
must be positive. Like the laws of physics mostly, Christopher. I'd say the laws
Well,
of physics are the ones that tell you that.
well, Thor's hammer pretty much ignores the laws of physics. Like for example, if you put it on an elevator,
Mhm.
elevator would go up, but if somebody picks it up, then it would just stay down.
Now, are we living in the world of the Avengers?
You never know.
I guess you're right. You're right. But let's just assume that whatever world your algebra test writers are thinking about is probably not going to be a magical realm. So I'm going to
Then
go
those
ahead and
people are not happy at all, and yeah, just live in a sad area.
I know. It is what it is. But in our physical reality, I would probably say that you can't have negative men and you can't have negative women. So these two make sense. Those are part of the constraints. It's basically saying like, hey, okay, here's everything that has to be true. You got to stay under 2,570 pounds. You got to have less than 17 people. And, you know, you got to be positive. Can't have any negative humans.
Actually, plenty of people are negative.
The people who wrote this test probably are. Okay. Last two, let's just see if these make sense. What would this one say if I read it out loud?
The amount of women have to weigh, well, men can weigh can be greater than or equal to 195.5 pounds.
Okay, what does the X represent again?
Number of men.
Number of men. So this is telling me that the number of men must be under 195.5. So this is telling me that I could have up to 195.5 men on the elevator. Does that make sense?
Oh no.
Oh no,
I
that doesn't make sense.
thought them in pounds.
It looks like it's going to mean pounds, but just remember that X, just a lonely little X, is just the number of men. We wrote it down. Oops. We wrote that down over here. X is the number of men. So if they put a lonely little X, that means that the number of men must be less than, which doesn't make any sense. What about the last one that we have? What is that? If I read that out loud, what would that say?
Number one can be greater than or equal to 17, which does work because they can be equal to.
So the number of women must be less than or equal to. Ooh, that's a lot of words, to 17. Okay, that makes sense, right? You can have 17 women, you can have less than 17 women. But what does it say in the problem? That the maximum capacity is 17 people,
Yes,
right?
but
I need
yes,
to account for the men and the women, which I actually already did. We actually already have that over here.
but
So
it
if
could be
you
0
don't
men.
account for the men, then that's not enough information, basically.
But men, miss, there could be 0 men.
Does it say
It could
that?
be- No, but it also doesn't say that.
Altogether, though, that's just not enough information. It doesn't give us enough. Because if you only mention the women, then basically the men would be able to do whatever they want. If there were 17 women on that elevator and 10 men came in, they'd be like, hey, it doesn't say anywhere that I can't get on. That wouldn't work. It's not enough information. So that's the process for this type of question. It is a little bit more lengthy, but there are some patterns, okay? So basically, whenever we see this, it's basically just telling me that you can't have negative numbers. And most of the time that's going to be true, because if you're in the real world, negative numbers don't really make any sense. So those are just a couple of extra additions that you might have on top of everything else.
Actually, negative numbers could work because you could be signifying how much money you're losing.
But it's only if it works in that context, which is why you have to read it very carefully and think to yourself, does negative numbers make sense in this case? Do decimals make sense in this case? And yeah, sometimes they might, but you have to read it carefully, and each question is different. All right. So with that in mind, let me see. Trying to figure out which of these I want to do, because we don't have time for all of them. Let's do this one. Yeah. So let's go ahead, and I want you guys to try this one on your own. Read it carefully. Try to see, okay, which of these scenarios matches 100%. And we're going to do part A and part B. So I'm going to give you guys a whole 5 minutes might be a lot. I don't know. We might not have time for the last question if I do 5 minutes, but I'll give you guys 3 minutes. See how much you can do in 3 minutes. All right, that is time. I know I didn't give you guys a whole lot of time, but I just want to make sure we have time for the last problem. So for part A, which of these matches 100%? For part A.
A.
A, good. Right, so a student may not serve more than 10 hours. So may not serve more than 10 hours. So that basically means they can't go over 10. So whatever they work has to be less than or equal to 10. Okay, then it says that a student must serve at least 1 hour per week at each task. So they have to do at least 1 hour of graffiti picking up and at least 1 hour of trash. So whatever they work has to be more than, greater than, or equal to 1. So that's where these symbols come from. Questions on part A?
No.
Good. Then for part B, we're just basically making sure that it's at least 10 hours and that, they have to make sure that they work 1 hour at least for each one. So does number 1 get you 10 hours or less?
Yes.
Yes. How about number 2?
No.
No, it's too many hours.
No.
Number 3?
No.
Too many hours. Number 4?
Yes.
Good, it's exactly 10. Number 5?
No,
No.
you need 1 hour for each.
Right, you can't do 0 hours of graffiti. You got to do at least 1. So that
And
doesn't
then
work.
the last one is a yes.
And the last one is a yes. So it was A, D, and F. Any questions on this one?
No.
Alrighty. Okay, we have 5 minutes. I don't know how much of this we're going to be able to do. So I think what I'm going to do is I'm going to leave this for tomorrow because it's just a longer question and I want to make sure we have enough time. So we are done a little bit early. I want to go over what is going to be on the test so that you guys can begin to study for it if you need to. Well, actually, everybody should. I should not have said that. Every single student in this class must study. Nobody here is going to get 100%, okay? You all have at least something to work on. So
Wait, but Miss, what if somebody does get 100%?
then I'm sure that that person studied really hard.
Also, during Christmas break, well, right before Christmas break, you said whoever does the best on the test gets $15 in Uber Eats. It was a 10.
15. And I will talk about that on the actual test day. There's going to be a little bit of an incentive, a little bit of a raffle going on for those who do really well on it. So that's definitely an opportunity. Make sure we're studying for that. So this is what's on the test. Basically everything we've learned since coming back in January. It's going to be solving systems of equations by looking at a graph, substitution, elimination, creating an equivalent system of equations. And I'm going to put a star next to that one because from my perspective, that's the one a lot of you guys struggled with during class that day. So I'm putting a star because that's something to focus on. Graphs of inequalities. So the shading, is it above, below, solid, dotted? And then finding solutions by plugging numbers in and figuring out if it works. And then finally, what we worked on today, which is word problems. All right, so lots of stuff on this test for sure. Definitely need to be working on that, practicing, studying, all of that good stuff. Tomorrow is going to be a review day. And then we test on Monday, y'all. So we only have about 3 more days to really feel good about all of these things. Do I have any questions on that?
There's school tomorrow, right?
Yeah, there's school tomorrow.
Okay.
Yeah. All right, and speaking of tomorrow, Khan Academy is due tomorrow at midnight, but if you want it to count for this marking period, when should you finish it by?
Tonight.
Tonight. So if you haven't done it yet and you want it to count, make sure you do it tonight. I'll be grading it during first period tomorrow.
Okay.
And last thing, sorry. If you've done any makeup work, if you went back and you did old Khan Academies, if you went back and you did old Teams assignments, anything at all that you've done in the last couple of weeks, let me know right now in the chat so that I can write it down and check your work.